So a 0 power, any base that is raised to the 0 power will always equal 1. It does not matter what the base is. If it's raised to the 0 power, it is always going to be equal to 1. Here's why. So if we have 4 to the 4th power, 4 to the 4th power means that you are doing what times what times what times what? 4 times 4 times 4 times 4, right? So if we've got 4 times 4 times 4 times 4, that's going to equal what value? What is 4 to the 4th power, or 4 times 4 times 4 times 4 equal? 256. Now, when I go down to 4 to the 3rd power, I'm now doing 4 times 4 times 4, which is going to get me to 64. So to go from 256 down to 64, essentially it's like I'm dividing, isn't it? It's like I'm dividing this by a 4, and that brings me to 64, doesn't it? Now, when I've got 4 to the 2nd power, that's 4 times 4. What is 4 times 4? 16. So essentially, if I'm going from 64 to 16, again, it's like I'm dividing by a 4, which is why there's one less of the 4s, isn't it? Now 4 to the 1st power. 4 to the 1st power is just going to equal 4. Again, it's almost like I'm dividing by 4 to get down to 4. So when I go to 4 to the 0 power, if I see this pattern, I'm consistently dividing by 4, aren't I? So if I take 4 and divide it by 4, what does 4 divided by 4 equal? 1, not 0. Those of you who say 0, 4 divided by 4 is not 0. 4 divided by 4 is 1. 20 divided by 20 is 1. 700 divided by 700 is 1. Okay, when you take a number and divide it by itself, it is 1. So this is just going to equal 1 whole. Every value, every base that's raised to the 0 power is always going to be equal to 1 whole. Okay, it does not matter what the base is. Okay, here I have in parentheses negative 4 raised to the 0 power. What is that going to equal? Not negative 1, just 1. Every base raised to a power of 0 is always going to equal 1. It will always equal 1. This is the easiest thing, guys. If you see a 0 power, it's a 1. If I've got 10,427 to the 0 power, it equals 1. Now here's the only difference. See, I have this one's in parentheses and this one is not. So essentially what this means, I've got a negative and then I've got 4 to the 0 power. That's essentially what that means. And 4 to the 0 power is equal to what? What's 4 to the 0 power? 1. So essentially this is like I have a negative or an opposite of 1. And what's the opposite of 1? Negative 1. That's the only time that you would have a negative 1 is if your negative is not inside the parentheses. Make that note. The only time it will equal negative 1 is if there are no parentheses. Parentheses around the negative. Around the negative number. Okay? That is the only time that it'll come out to a negative 1. Only time it comes out to a negative 1 is if you have a base that's negative but it's not written in parentheses, then technically the base itself was not negative. You are only raising the number to the 0 power, not the negative sign. So remember we talked about how important it is to put your negatives in parentheses What else are we supposed to put in parentheses when we have an exponent? Negatives and what? Not positives. Fractions. Negatives and fractions need to be placed inside of your parentheses when you have an exponent involved. Okay? Here we've got a to the fourth over a to the fourth. Remember yesterday we learned that if it's division, what are we actually doing to the exponent? Subtraction. When it was division, we are actually taking these exponents and we're subtracting them. We're doing 4 minus 4. And what's 4 minus 4? What's 4 minus 4? 0. And what is any value to the 0 power? 1. So it doesn't matter that it was a variable to the 0 power. Does not matter. Anything to the 0 power is going to equal 1. Okay? Go ahead and finish off the rest of them. Finish off the rest on that front page. Again, 8 to the 0 power, what does it equal? 1. Vincent, look up here, honey. Always equals 1. If it's raised to the 0 power, it always equals 1. So Vincent, what is this going to equal? Vincent. Vincent, leave my room. Nope, bye-bye. Take your computer with you. I'm going to have you log in later. You're going to do the whole thing, and you're going to have to learn the notes on your own. Okay, we have negative 7 to the second power over negative 7 to the second power. Again, they are the same base. So you're taking negative 7 and you are going to subtract those exponents. So you have 2 minus the 2. Go to Mr. McNeely's room. That's going to equal negative 7 to the 0 power. And again, anything to the 0 power always equals 1. Anything to the 0 power is always equal to 1. 18 to the third over 18 to the third. You keep the base, you subtract the exponents. You're doing 3 minus 3. That's going to equal 18 to the 0 power, which is going to be equal to 1. Negative 16 to the 0 power. What is that going to equal? Negative 1. Why? Because there is no parentheses. Okay, so that basically means you have a negative, and it's 16 to the 0 power. And we know 16 to the 0 power is 1, but you got the negative on the outside, so the whole thing is going to be equal to a negative 1. Okay, so 0 powers, very, very easy. If you have it to the 0 power, it is a 1. Go ahead and flip it on over to the back. Negative exponents. There is such thing as a negative power. You can have 5 to the negative 3rd power or 12 to the negative 8th power. We don't like to have negative exponents written, so we always rewrite them so that it's in positive exponent form. When you rewrite it, what you're essentially doing is you're taking your value and you're turning it into what we call the reciprocal, meaning we are flipping this value upside down and we're putting it as 1 over whatever your base was. The base does not change, and let me reiterate that one more time. The base does not change. The base is going to stay whatever it was. If the base was positive, it stays a positive. If the base was negative, the base stays a negative. The only thing that's going to change is the exponent. The exponent then becomes a positive exponent. Your exponent would then become a positive exponent. Let me show you why. So if we have x to the 5th over x to the 8th, we learned yesterday that essentially it's like we are canceling out x's on the top with x's that are on the bottom. But in this case, Yesterday, you had more x's on top and less x's on the bottom. But here today, I'm showing you where you've got more x's on the bottom. When I go to cancel them out, cancel this one, 2, 3, 4, 5. I'm left with x on the bottom, not on the top. So I can't write x to the third power. What I can write is that x to the third is in the denominator of a fraction. And what would I put up top then? What invisible number always exists? A 1. We would put an invisible 1 up at the top. So here, when we're looking at this, this essentially is me saying, hey, I'm taking x and I'm doing 5 minus 8. But 5 minus 8 is a negative 3. So x to the negative third power is 1 over x to the positive third power. That's how negative exponents work. You are just flipping and making a fraction 1 over whatever your base was, and then changing your exponent to a positive. So let's take a look at this first example. We have 4 to the negative second power. 4 to the negative second power. I'm going to go ahead and do the reciprocal. I'm going to keep my base. What was my base? 4. And where's the base going to go? On top or on the bottom? On the bottom. So we're going to put 4 on the bottom. What's going to go on top then? Nope. What value always goes on top? A 1. A 1 is always going to go on the top of your fraction. And now my exponent, which was a negative 2, now becomes a positive 2. So it's now 1 over 4 to the second power. Okay, if we look at the next problem, we have 12 to the third over 12 to the 8th. We've got to follow our rules first. Remember, our rule says we keep the base, we subtract these exponents, so we're going to do 3 minus 8. What is 3 minus 8? Negative 5, not 5, negative 5. The order that you're subtracting matters because we're now creating a negative. This is a negative 5. Again, we don't like to have negative exponents. We don't like to have negative exponents. So what we're going to do is we're going to create a fraction. What's always going to go on top of my fraction? A 1. My base, what's my base? What was my base? The 12. The 12 was my base. And my exponent now becomes positive 5. So you have 1 over 12 to the 5th power. Okay, for the next problem, my base is a 3. My exponents are negative 2 minus negative 5. Use your calculators. Do negative 2 minus negative 5. Negative 2 minus negative 5. What do we get? Positive 3, right? So here we are. We're good to go. Just because you see negative exponents doesn't always mean that you're going to have a negative exponent as your final answer. You need to still follow your multiplication and division rules. That if it's division, you subtract them. If it was multiplication, you would add them. And then you follow your 0 power and negative power rules. Always follow product and quotient rules first. Then you adhere to your negative and 0 power rules after. Okay? Take a look at the next problem here. Our base was a 5. My exponents are 3 and 7. I need to subtract them because this was division. What's 3 minus 7? Negative what? Negative 4. 3 minus the 7 gives us negative 4. Can I have a negative exponent? No, I cannot have a negative exponent. So we're going to rewrite it. What's going to go on top? A 1. What's going to go on the bottom? 5 to what power? To the fourth. 5 to the positive fourth. Now, I know I keep showing you guys a whole bunch of like, oh, we're taking the quotients and when we subtract, we're getting negatives. Again, it could be the same thing if you have a product. So let's say that I've got 6 to the negative 8th power, and I'm multiplying it by 6 to the 3rd power. If it was a product, who remembers what do we do? We have the same base, but this time it's product. What do we do with those exponents this time? Add them. When it's a product, we would add them. We take negative 8, and we're going to add the 3 together. Negative 8 plus 3 is going to give me a negative 5. So now I need to rewrite this because it's a negative exponent. So again, it becomes a fraction. What goes on the top? A 1. What's going to go on the bottom? 6. Just 6? No, 6 what? To the 5th power. 6 to the 5th power. Pretty simple enough. Okay? When we come back from lunch, what we're going to do is we're going to work on a live quizzes. It's going to have some of our multiplication and division. So it's going to have some product and quotient rule, and it's going to have 0 power and negative powers incorporated into it as well. Go ahead and line up.